Now we got it. So why high environmental adaptability matters in CNI and energy system storage. So, which is a very important part. So today we gather to discuss a critical aspect which is often overlooked in the energy storage system, which is very important. How drastically different operation environment create monumental challenges for safety design. While the importance of safety in ES has gained widespread recognition, the profound implication on environment diversity remains significantly underappreciated, which means that the safety part is one of the most important ones. And we took time to go deeply in details and to understand how we can improve it. And I will show you today how we did it the last years. So that's just to give you an approach how it can happen. So in 2011, as you can remember, we had this Fukushima headquarters and this tsunami event, which actually leads to a disaster. So we have this phenomena of headquarter and tsunami that we have also to take into consideration. 10 years later, we have the Hurricane Ida struck in Louisiana in USA. And this part is also very important to be considered. So we have two phenomena here, which is natural catastrophic that we it happened the last 20 years, and that we have also to figure out and to take into consideration. So how we did it, we just review here in this slide the various working environment that we have to face the last years and how we have to, what are the challenges of this part. So one of it is a spray, the high temperature or even the deep temperature that we can have, the sand, the dust, the UV, the challenges that we have to face, the humidity, and also the chemical corrosion, which also a very important part, just to make sure that the safety can be relayed. The fire prevention, this is what I highlighted before. I will give you more information about this part. The ventilation, also important part, just to make sure that we don't have any overheating or down cooling. The humidity, the electromagnetic part, which is an interferences that can happen, and the worst case that would happen already, this is the headquarters. And this phenomena we studied the last years. And I give you here an overview of what has been done up to now and what are the results. Let's go in details now on that topic. How we increase the whole system lifespan. So on two ways. The first one is the material selection, which is one of the most important part, just to make sure that we are providing the right materials for the right environment and working on the right condition. First. The second one is to have the right process optimization. Now we are talking about the design of the product as cells, electrolyte, modules, system, up to also the production lines. If you have everything set, but you cannot produce what you are setting, then you have a big issue. And this is what we have in one hand here by Pylontech. And we are providing this solution. On the two high drastic temperature issue that we have to face, we have the high temperature environment above 50 degrees Celsius, and we have a very low temperature. So now you have a better understanding what I was talking about. So the first one is the high temperature and also the low temperature. So I will give you more details on that topic. For the liquid cooling system that we have here on our boat. We have also here on the left side, the FIDUS product for residential application. You can have a look, it go up to 55 degrees Celsius and even lower up to minus 20 degrees Celsius. So what are the consequences of high temperature? The first one is actually the increase of the thermal runaway risk, which is very important to minimize. And for low temperature, we have a short circuit risks. And this is what we want to prevent. So I already highlighted the different natural disasters that we already faced last year, like earthquakes, strong winds, and other factors like very high altitude, above 3,000 meter, or the coast area with salty environment, or the mountain region with the snow load or wind, etc. So let's move forward, give you directly clear understanding what's going on. So the current development and challenges of the CNI looking is based on the temperature control technologies. This is what we have here on that cabinet, and also in the containerized solution, the structure design, and the intelligent monitoring. I have to move forward, otherwise I will not be able to show you the result that we have. So on the challenging encounter, they have the temperature adaptability with very high temperature. The liquid cooling has to be make sure that the heat transfer is working properly. On the structure design, we have the temperature, the corrosion, the snow, the ice, and the application, just to make sure that our battery is providing the right solution on the right voltage, the right capacity also. So let's move forward to the intelligent temperature control. So we have here a container and cabinet solution. You see this is L260 and L5000. So the adjustment of the function, the hot start and cool start function, the precise temperature control, and the low power. I will show you some graphs that you have a better understanding what does it mean, that you can also figure out by yourself how we can move forward on that topic. So what we can see here, this is some tests that we proceed. It was on the container solution, I think so. So what we can see on the above or left side, the figure number 1 is the cell temperature differences, starting with the minus 25 degrees Celsius. That you can see that you have two different curves, the two green curves, the minimum and maximum temperature on the cells level. So this is in the same unit. And then we started at minus 25 degrees. And you can see here that we have something like less than 5 degrees Celsius differences. And then it moved, the cell temperature is increasing. After almost 12 minutes, we achieve something like 5 degrees Celsius. And you can see here that the temperature differences between the minimum and the maximum cells is less than 5 degrees Celsius. At that time, then you can start to work properly, and then you make sure that your cells will be provided the right voltage and the right power. If we move forward, so we keep working on that increasing the temperature. So we have the number 2. So we can see here, this is the standard working temperature mode. Now we move to the number 3, the phase 3. You can see here, after about something like 25 minutes, then we increase even more than, let's have a look here, more than 30 degrees Celsius. And we can still here see that we have the temperature differences between the maximum and the minimum less than 5 degrees Celsius. So then we stop the test, and we see that the temperature dropped down, and the differences is still the same. We have actually always less than 5 to 10 degrees Celsius. And if you see here on the right side is the curve number 2, you can see that the temperature cells are at 45 degrees Celsius. So we started with very high temperature, so 45 degrees Celsius, and then we try to regulate the temperature. So the point here is actually I want to highlight is that we monitor the temperature for every single cells in this case, just to make sure that our whole system is working properly. So we started with very low temperature, now we start with very high temperature. So you can see here that the differences at the beginning is for the minimum and the maximum is quite huge. You have almost more than 10 degrees Celsius. And then we started to cool down the system. So the first phase is still actually not in operation mode. So we just make sure that the cells they get the right temperature before we start working. And then you can see here that after a while we have something like 5 degrees Celsius differences between the maximum and the minimum cells. It's go through the for the whole test time, and then you see that we have almost for the whole test something like around 5 degrees Celsius differences. So for the charging, we have the number 3 during 2 charging. So we charge and discharge. So you can see here, this is on that part here. You can see here that the maximum minimum is less than 10 degrees Celsius at the beginning, and then we move forward on the temperature. So we make here 1 charging, 1 discharging, and 2 cycles. And you can see that it's still actually the difference temperature between the maximum and minimum is still actually almost similar. This is on that part. On the right side here, we make something similar, where we have the maximum and minimum cell temperature for rating power. So we make also here different cycles. And then we see here also that the maximum power, so we actually here, we cannot see, we can see it actually, this is the red curves. So we are providing power, so charging and discharging, and then you can see here on the time that the temperature on the right side here, that is increasing by charging, and then we have here, by discharging, we have here a drop, but the temperature is exhausted. So this is to give you an overview what we achieved on the temperature level. So the temperature control is very important. We did also different tests. For instance, the structure design, which is very important. We talk about headquarters, we talk about seism. So this is something that we take into consideration, and we want also to make sure that when we provide the solution, we provide the right solution. So the first one is the lift. So if you have some container of some cabinet, you have to lift it, and then we make the measurement how will be actually the load of this cabinet when it's completely full with battery system. It can be the L2. We move on the number 2. Oh, sorry. So this is what you see here about the number 1. So the number 2 is over there, the wind test that we make the simulation. So we also make sure that when we have a very strong wind on the container wise, with a certain angle that the container will not move. And we make many tests on that topic, and we make also the simulation here. So you can see also for Germany and Austria area, we have the snow load simulation test that we provide here. This is in the middle here, number 3. And we make also the different tests for the seism simulation and also for the transportation. So you have a better understanding what we are actually testing in our product. Is not only to put some battery in a container, is also to test that the whole system is working properly. Here, this is an example of the transportation part. Almost finished. So this is the optimization structure. So what we did is we put here a sensor in the transport. We have our battery inside, and we just measure how does it work and how is actually the load on the mechanical part. And actually we drove something like 5,000 kilometers around China, and then we have actually the results. And we figure out that actually all the battery system has actually no influences on the transportation. So here I want to highlight the multiple safety design. So we have here 6 different parts. The first one is the BMS part, which is very important. The second one is a multiple protection mechanism. We highlighted during this slide. The mechanism safety design, we highlighted here with different simulation that we proceed. The electrical safety, it's not here in this presentation, but we can provide you with more information in the future. The next is the fire suppression system, I highlighted also, and the environmental monitoring system on part. So here, this is a certification that we can provide for every single product. So this is here highlighted. I'm trying to have the last slide. I have the feeling that it does work. I just want to highlight actually in this case that the quality control in our part is not only about the design, it's also on the production part, just to make sure that it's fulfilling our quality criteria, which is a very important part. So the whole system with the MES in the production line, the troubleshooting part, also the intelligent production lines, this is also integrated in our factories. The automatic logistic control system, and also the production data collecting and recording. That means that even if we have something solved, that we can track what happened during our production line 2 years, 5 years, even 10 years ago. So we can control all this part and just to make sure that it will work. So thank you very much. I'm over the time. Sorry about this. I can talk about hours long about this topic, which is very important. I hope that I can provide you a right an overview of what we did the last years and our progress. Thank you very much.